All right, good afternoon, everyone. My name is Eng Ong. I'm a quality engineer with Mouette. Apparently, I'm quite vertically challenged, so I'm going to try to see everyone. Today's topic is how do we get mobile applications into a CI environment? And just out of curiosity, how many of you have actually integrated tests into your CI environment, mobile application tests? Can I show of hands? Not many. Oh, very good. So hopefully the people who have done it, it will be great to compare notes, and also and the majority of you will have some practical tips that I try to include in this session, so that it's something you can take away and apply to your day-to-day work. All right. So what are we going to cover today? The main part of our presentation will be about the basics, but we're going to start looking at the challenges that you will face. What are the challenges in mobile applications space, which is different from web applications, that makes it more difficult for us to integrate into our CI environment? Then we'll take a look at the two main part of the presentation, which is trying to understand what is the basic Android and iOS, the two main platforms we're going to pick. How do we interact with the simulators, and how do we set up, install, and all the challenges that you'll face when you try to integrate a mobile application test into CI environment. The next part of it is that after you get your environment set up, you need to have tests to run, and what are the tools available, and what are the choices you have, and I'll provide a guideline, as in what tools might be suitable for your application, and hopefully that will help. And finally, I'll have a demo to show you how a test can run in the CI for both Android and iOS, and it's a reusable test as well. So let's take a look at the first section. So the challenges for mobile tests. As we all know, your mobile application test would have, you start off with Android or iPhone, and maybe you have more Windows, and so on and so forth. And within each platform, you would have challenges like the device manufacturers, it is different. You have the operating system, your resolution, your screen sizes, whether the phone has tints, and all that, all the different hardware that comes with your along with all the setup challenges that you're going to have. And not just for smartphones, you have to think about tablets. Would a test also run on tablets as well? And the next part is how you integrate the choice that you make, choosing the platform and which OS and so on into a CI environment. The challenge you're going to face is pretty much standard. You're going to find out that you need to know how to set up your tests. How do you set up your emulator? How are you going to install, uninstall? How are you going to make sure that the connectivity to the emulator devices is reliable and consistent? And once you got that, you would have to go ahead and try to execute your tests and tear down and make sure that your tests can be run reliably over and over again. Then you also have to think about what your test results. Are they going to reside in your emulator, and how are you going to pull that out and actually display it into Jenkins or any CI environments, right? How are you going to display and publish the results from the device? So these are some of the challenges you're going to face. The next challenge you're going to face is, there are so many technologies, so many tools that are available in the market right now, especially over the past few years. They have a ton that's surfaced, and you think about what is the right tool for your application, really. And we're going to visit that. So that brings us to, we're going to try to tackle the mobile integration as well as the technology in this session mostly. For as far as platforms, it's really app dependent. So if your mobile app has features that really relies on the device, then you have to pick the device to integrate into operating system, into your tests. In CI, but if your test can run as much as you can, testing functionality-wise on the emulators and simulators, the advice is, rule of thumb is, run as much as you can in your simulators environment, because it's inexpensive and you can run it in your day-to-day builds and as often as you can. So that's one option. So that's why the focus of the presentation will be mostly on simulators and how you can actually integrate that into your CI environment. So let's take a look at how to set up on Android and iOS. I'm including quite a few tips that these are practical tips that, some problems you'll find, some of the learnings I got when overcoming a lot of the hurdles, trying to integrate Android into CI. So the first thing you need to do is to set up, right? You have to run the emulator, and the command you give it is, with input of Android virtual device. This is basically just a properties file that, you can configure your operating system, you can configure your resolution, memory, and so on and so forth. And you can, create that with the Android tool. So once you have that, you can also configure it with multiple options. You can have, you can reset user data. You can have no animation on startup, no audio, and so on and so forth. So the first tip, would be great if you could use the Android emulator plugin. So I know that this comes with Jenkins. I'm not quite sure whether it comes with any other CI environments. You might want to check it out. So what this does is that it helps you start the emulator. It helps you install, uninstall. It actually does a cleanup for you, and it's something that you could have a user interface in CI environment to just pick and choose what you want. You can choose your startup options and so on and so forth. It's really is really clean way of doing things. The only limitation I found so far is that if you're using a geolocation, your app uses a GPS feature. So what you want to do is you want to actually test with a mock locations. So you're sending in to Android your geolocation fix. So that's a command that you telnet to your device and say geofix, latitude, longitude. When you do that, you have to start up your app and pass in all these data. You're not able to connect that during runtime. You're not able to connect to the emulator because Android emulator plugin uses a random port to start the emulator as well as a random port to start your ADB. So this poses a challenge. So as open source goes, it would be great to have that fixed in the future, and then this will be a seamless integration into CI. All right. So listening to is when you use an emulator to start up, on Android is quite notorious that it takes forever. It takes about a minute and a half if you start from a clean slate, clean image. So what you want to do is actually use a snapshot image. So the snapshot image is only pretty recent actually that Google supported that. And what you want to do is just give a snapshot. The default dash boot is the default snapshot image, but you can always create your own. And the option, which is no snapshot save, it's useful when you don't want to save the last state of your emulator when it closes. So this is a default feature. If you don't specify the command, it's going to be saved. However, there's one limitation about it. When you save your snapshot, what happens is that it saves the time and date when you reopen the emulator. It's going to be, the day that you saved the snapshot. It could be like a month ago, a year ago. So what happened is that this is a limitation if your test requires your current time, date and time. So that brings us to the next tip. So how can we overcome that? So the ADB Shell is a command line tool. If you're familiar with Unix, this is really simple. When you type ADB Shell, you're actually thrown into a shell that you can type different commands, and it will interact with the emulator directly. In this case, all you have to do is set the date command, and you'll see the change of the date on the emulator to the current day and time. The next thing is, if you can't use the emulator plugin, like one of the examples I quoted before, you would want to use the emulator command. You want to start up the emulator. What you want to do too is that you want to check the status of your emulator. Sometimes you can't connect to it. You could run ADB devices and grab emulator and you get nothing. So what you want to do actually is to restart the Android debug bridge. I know that for a fact that I think the emulator plugin does that automatically for you. It checks the status, and if it doesn't, it just restarts the server. So this is something to keep in mind if you have to run it, do the manual, startup yourself. And if you can't use a snapshot image, the useful tip to know is that when you start up your emulator, the first thing that happens is that it locks the emulator, right? You have to unlock it. So what you want to do is actually send a menu command, a key event, such that it will actually unlock your emulator, and that's the key code 82. The next key event is actually a mask key. What it does is that it prevents the emulator to go back into to prevent us from using the touch screen mode, because the previous was a key event. So you just want to revert that and make sure that the touch screen still works. All right. So now we've seen all the tips for Android. How about iOS? There are a couple of ways to start iOS. You can use the open command, which is a generic Mac OS command. Or you could use, if you want to use iPhone simulator, just purely iPhone simulator, you can use this iPhone sim command. This you have to download from GitHub. It's basically just a Xcode project you just built, and it's really easy. If people don't want to use the instruments command, they could just, you can build the binary for them, and it can just easily launch your app. So I found that some people who wants to check out our app, we could just ask them to just launch just like that. So it's really simple. The other way is to launch with Instruments. Instruments is a developer's tool that comes with Xcode. So what you want to do, well, not just Xcode, but just Mac OS. So what you want to do is actually create an automation trace template. So you just want to open Instruments, create an automation template, and save it, and pass it as an input to Instruments. And just give it your app name. Your app name has a full path name. If it's on the device, you just have to specify the app name, .app. And a device, if you are connecting to a device, you need the UID of the device, and so on and so forth. And also in iOS, it makes it really easy for you to just launch your tests. You can launch your tests using instruments as well. So basically, you're launching the simulator, and you're also launching a test with the same command. And you can pass in where your script location is, as well as your results, where you want the results to be. All right? So a couple of things. So one thing about when you reboot your Mac, or you use the iPhone simulator for the first time, you'll see this prompt, like developer's tool is trying to gain control of your by in a process, and you have to type in your password. So sometimes you just type in password and forgot, but this happens like if you reboot your machine, or you reinstall Xcode. So what you want to do is actually there are two ways of going about solving for this. The first way is to add the user into the developers group. The other way is what's listed here, which works generically for everybody who uses the built machine, which is to just add to change the allow root key in system privilege task port to true. This will prevent the next time you won't see this prompt again. So this is really useful when in a CI environment. The next thing is if your app uses preferences, caches, and SQL. Where can you find it in your simulator? So this is also an advantage when you use a simulator versus a device, because you need a jailbroken device actually to access all these data. But in a simulator, you can actually go to this directory and find where your data is, and you can do your cleanup. You can find out, you can verify your data, and so on and so forth. So we've seen how to set up. So it's one of the more complex ways of solving for integrating CI. But what we have left is also install and launch. So let's take a look at that. So on install, Android has a separate command, which is to ADB install. All you have to do is give the APK file. And you can also install multiple builds. If you have multiple builds that you create with different configurations of the apps, and that's what we do. And we can all install at the same time. For uninstall, you actually need a package name. So where can you find package name is in your Android manifest file. The package is in the package right at the very top. So you need to figure it out to plug it in CI. As we've seen earlier, iOS, you don't need that because it's all in an instruments command or in iPhone sim command. So you can just directly use that. So how do we launch in Android? Android, again, the ADB Shell has this command, which is Activity Manager. And what it does is, it starts the activity. Again, you need to figure out what your activity is. And once you figure out, you can just launch the activity of your app. A quick way to find out is that when you start off your app, you can have DDMS running, which is a debug console that you can actually see, what activity is being started, and you can actually plug that into your start command. And similarly for iOS, you don't need that because that's part of the setup. So we've seen install, launch, and setup. How does that all fit into Jenkins? CI, sorry about that. So in mobile tests in CI, first thing is a standard thing. You have to create a new job project, and you want to have build triggers. You want to have build steps, right? And part of build steps would be, when you inject the commands to start emulator, uninstall your app, install your app, and launch your tests and execute a test, and finally to publish your results. So this is a standard procedure that you want to complete when you integrate a test in CI. So with that, we've seen the first part of how to solve the problem of integrating your emulator and simulator into CI for Android and iOS. The next key part is to figure out what are the tests to execute, right? How do you automate your tests? So that's what we're going to look at. We're going to look at, in general, first try to understand what are the automation technologies. I can bucket all the technologies in the marketplace into two different categories. The instrumented and non-instrumented approach. What do I mean by instrumentation? So instrumentation itself has a strict form and a less strict form. For example, a strict form requires you to have the source code of the application, which means that you want to actually compile your tests with your source code, your actual mobile application, and you also want to launch your tests together with your mobile application. So a good example of that would be Robotium. Robotium requires you that you create a test project and you add your source code, your mobile application, as a dependency to your tests. And if there are bugs, if your code can compile, your test won't compile and your test won't be able to install. So there's a dependency there, and that's a strict form of instrumentation that requires your source code as well as your to be included as part of a test. Then we talk about a less strict form. It would still sometimes require source code and may still need to modify the source code in order for your test to run. A good example of that is iOS, the UI automation library. So what it does is that it uses the accessibility feature to allow you to have hooks into your mobile application such that you could use those hooks to drive your tests. So you've seen the command that the reason why we're not running our tests in the app is because of this feature that enables your test to run. However, your mobile application would have to enable the accessibility feature for this to work. This is a hook. This is the hook that makes your test runnable. So it's a less strict form of instrumentation, but nevertheless, it is instrumentation. And the final two characteristics are generic for all mobile application tests, is that only one application can be executed at the same time, as also known as white box approach. So instrumentation is you've noticed that if you want to switch between different apps, you want to work with multiple apps, you can't do that with instrumentation because your test resides either in the sandbox of your application or it resides in the device, right? It's not able to reach out to another app or reach out to externally at all. So helping to understand what is instrumentation, you can also flip the coin and you know what non-instrumentation is. So non-instrumentation doesn't require you to have source code. It doesn't require that you compile your tests together with your source code. And you can also access multiple different applications because it doesn't reside in the sandbox of your tests in your application or the device. So you're seeing this as an external party, and it's also known as a black box approach. So now we understood what are the characteristics of both techniques. Can we maybe now dive in deeper to look at the advantages of two different techniques? So you can look through and the advantages. Just go through the advantages of a non-instrumentation technique. Is actually the advantage of the advantages of non-instrumentation technique is a disadvantage of a non-instrumented technique. So you can see it as a different way. So for example, a non-instrumentation technique is device platform agnostic. So you can run your tests on multiple different platforms. I can have a set of tests that runs on Android, a set of tests, the same test could run on iPhone. And why is that? Because it's outside the sandbox of the application, and it's not tied into the platform that you have to run your tests in. This makes allow you to reuse your code, and you can have test language and harness autonomy. And also we talked about having that you can test with multiple applications. The other thing is custom UI. You probably have seen, if you work in mobile applications a lot, typically there will be custom user interface in your application. And what happens in custom user interface is that when you're in the sandbox and you try to see the elements in a custom user interface, you're not able to see anything because it's a custom UI that is not exposed to the APIs, in, say, of the instrumented technique. If that's the case, you're not able to run your test. You're running the test like randomly. The only thing you can do is all the different gestures, so you hard code it. That's the limitation of instrumentation technique that becomes an advantage of a non-instrumentation technique. And also, if you need to do database and API assertions, server-side API assertions, or your external libraries, like if you have a lot of images that you want to verify and all that, and there are so many different image libraries that you could use, but you can't use that in an instrumented technique because you don't have those libraries in your application. So that's an advantage of using a non-instrumentation technique. You can see all these advantages. It's also the advantages of non-instrumentation. It's also a disadvantage for instrumentation, vice versa. The key advantage of instrumentation technique is that you can access the elements. What does it mean by that? Because when you can access the elements, you can see what type of elements your UI, your application is using. For example, is it a text? Is it a text field? Is it a button? Is it a table view? All the different UI elements, you're able to see the type, the name of the elements. You can see the content. What is the text? To verify and so on and so forth. So it does have its advantages, and also the ability to. It comes typically in instrumentation approach. You can. It's built in. It's so much easier to install, uninstall, launch your app, and so on and so forth. The other key feature is that you can do a code coverage. You can't do that with a non-instrumentation approach because you need the hooks in order to access how much code you hit as part of code coverage. So now we've seen both techniques. Now we have to understand what technique is better for your app. It's really the two sides of a coin. It doesn't mean that one side is better than the other, but it really depends on what your application is about. If your application is more suited to use the non-instrumentation technique, some of the features cannot be tested with instrumentation technique. You have no choice but to use non-instrumentation, and vice versa, right? So I want to just generalize and offer you a better understanding of which technique to use. So maybe this pie chart would help. So you can see that if your application is mostly text-based, you need to verify, for example, a tweet, a user's activity, a user's account name, available balance, and so on and so forth. You want to validate the exact text. You want your instrumentation technique because then you can get the data and validate, and you can be sure that it's 100% correct. So hands down, with text-based features, you want to just go with instrumentation technique. But if your app has many features that it includes images, custom UI, external validation that you have to do, and as well as external interaction. For example, we have a feature that requires a user to log into a mobile device, and the user has to validate their identity with SMS message or an email. So then the user has to step out and go to their web to web app to validate the user, and comes back to the mobile app to continue the process. So this is also known as out-of-band authentication, and this approach cannot be used using instrumentation because you have to step out and you have to step off of the app and work on some events before you can carry on your mobile device. So this is just one example. So having known these two techniques, we can take a look at the tools that are bucketed in these two areas, and they are very distinct. You can see you have a set of tools, in instrumentation and for Android and iOS, and these tools can be grouped into multiple. This is by no means an exhaustive list. Basically they're mostly open source, and with the exception of Eggplant and UI automation. So what the tools that are available in instrumentation are mostly can be grouped into different languages. They vary from Ruby, Cucumber, and CoffeeScript, and Objective-C, as well as JavaScript, as well as Java. So you can have a choice of different languages that your team is more comfortable with. The only Java base is actually Robotium. And if you look at non-instrumentation, with the exception of Eggplant, you could see that every tool listed there is based on Java. So that's what we're going to use for our demo, which is actually to be able to use the tools that we can run our tests on both Android and iOS, and actually use the same test harness to be able to drive the tests. And if time allows, I can just do a quick walkthrough of a Robotium test in CI as well. So having known all these tools, we'll just jump in to look at 3 different tools we'll pick. Will be MonkeyRunner, Sikuli, and Mouette, right? So what is MonkeyRunner? So MonkeyRunner is the API that controls the Android device emulator outside the Android code. So MonkeyRunner, by virtue of its design, allows you to use the same command to run on an emulator as well as the device, which is is fantastic. Not only that, it does a lot of different, it does all the user actions that you can possibly do on an Android device. It captures screenshots. You can also do admin work, which is start, stop, connect, configure your logging. It also does multiple device interaction. You can actually connect to multiple emulators and devices with a device ID, which is kind of cool. However, how do we use MonkeyRunner in Java? There's very little documentation around that. So the next few slides will help you integrate that into Java easier. A couple of things you need to set up is, of course, download the Android SDK tool. The SDK has a set of tools and platform tools as well as tools directory. You need both of them. And then these are the list of jars and list of classes that would be of interest to you if you want to integrate that in your Java environment. And how do we actually use these classes? If you look at this set of code, there's a really important object you have to instantiate, which is the ADB backend connectivity. So this will connect to the emulator or device. You need to make an instance of that, and you basically call the wait for connection. And with giving your timeout and your device ID, I think device ID is optional if you only have one device running on your system. And it will give you an instance of a device. And with that device, you could actually connect to it with different commands that allows you that you can do on the command prompt. So you can execute ADB Shell commands, pretty much any command in Shell. For example, killing a process ID, start an activity, and different key events like touch screens, drag, and so on and so forth. Keyboard events as well. And the last thing is, of course, you can type in any text that you want in the fields. So you can see more of different APIs that is sort of integrated into a simple Java command that you can use, and like dragging, getting screenshots and all that utilizes MonkeyRunner and make it easier for you to integrate into your Java code, Java tests. So we've seen what MonkeyRunner does. Let's look at what Sikuli is. Sikuli is a visual technology that you can use to automate and test user interface using images. So Sikuli is more of a generic tool compared to MonkeyRunner. MonkeyRunner is just for Android. So Sikuli is a pretty neat tool that you can not just automate your mobile app, you can actually automate all the events in your operating system. If you need to control different apps, you need to control different commands, or or you can need to verify your database and all that. You can do all that separately, but Sikuli is just a set of commands that allow you to recognize images and around your desktop and control anything that is like a user behavioral technique. And it can mimic that, and you can use it easily as part of your tests. So the nice thing about Sikuli is that it's platform and OS agnostic. So you can control your desktop, you can control your simulator and devices via VNC. So it does the standard, some of the actions that you'll be useful for mobile testing is capturing screenshots, detecting screen changes, keystrokes, and finding images that you can tap on, and as well as image OCR. The OCR is kind of pretty rudimentary, but nevertheless, if you have a really simple, text, which is a clear image, you can actually get the full text pretty consistently. How do you use Sikuli in Java? Sort of the one thing you want to do is to just install the IDE. You have to install the IDE. It's not just a Jar file, because it has quite a few dynamic libraries, runtime linking libraries that you need to link to. And then once you install the app, you want to import the script Jar file and start using the APIs in the script class. A couple of important classes here. Let's take a look at how we can actually use Sikuli in Java. So the key thing here is that you want to make an instance of your application. The application is, say for example, iPhone Simulator is your iPhone Simulator app, so that the Sikuli will know that it has to focus on this application alone. And you can set the screen. Once you get the application, you can set your screen to zoom into the app, and whatever activity is going to happen just in your application screen. So then you can do things like you can click, you can type, you can capture screenshot, and so on and so forth. So again, for more APIs, you can check it out at com.intuit.com, com.intuit.mouette.iphone.java on GitHub. And I have the resources at the end of the presentation. So the next tool I want to take a look at is Mouette. What is Mouette? Mouette is I like to see it as a design pattern. Most people just jump in and design. But when we think about the mobile apps test, we have a suite of tests that runs the same way on different applications, because your application is exactly the same or mostly the same on different platforms. So if you like to have the same set of tests that can run on different platforms, you want to think about design. You want to think about how you can reuse your tests on all these different platforms. And to do so, you want to think about using a creational pattern, which means that that you can at runtime instantiate the right device and bind it to your tests to run your tests. And I'll show you exactly how to do that. And in this way, you can actually reuse your tests, and you can also use the same language and same test hunters to run your tests. And this gives an example of a login test. So a login test can be specified as a part of an interface, right, or your application interface. And when you implement this interface, you can implement in iPhone, you can implement in Android, and so on and so forth. So when you implement this interface is when you implement how you complete your action of login on iPhone. So this example shows you that you touch the screen at certain, at the username, and you enter your username, and so on and so forth until you submit. But for Android, you might have a different way of implementation, so then you have to implement it a different way. But this means that if you follow this interface, and all your tests is based on this interface, you can create as many implementations on different platforms as you want, but you can reuse your tests on these different platforms. So how does the architecture look like? So we talk about the application interface. This is the top layer. You define all the business logic. say, for example, get accounts, do a transfer, do a bill pay, for a financial application. These are login. You define that as part of user interface, your application interface, and then you base your tests off that. So because your test is based on this interface, you know for a fact that these are being implemented in different platforms, that you have. So what you have is an implementation of Android, and it will reuse all the features as part of the MonkeyRunner library. And on an iPhone application, you can reuse all the Sikuli libraries that you have built already. What makes this interesting is that you're actually abstracting two things. You're abstracting the device, right? You wouldn't know what device you're running, right? Because it's sort of encapsulated in the, during runtime, in the simulator layer, that you wouldn't know what device you're running. The other thing is also encapsulating the user logic on how you implement your business logic and how it is being implemented on the device. So these two forms of abstraction helps you to just be able to run your tests on multiple devices. So now we will take a look at the demo. So what I'm going to do is actually run a mobile test in CI with MonkeyRunner, Mouette on Android, and Sikuli and Mouette on iPhone. You'll see that we'll be able to run it, install an app, launch an app, run tests, and stop the app, and publish the results. Right? All right. Let's see. So what I'm going to do, you can see. So this is a Jenkins build. I have NonInstrumentation Approach and an Instrumentation Approach. Let's start with the NonInstrumentation Approach and look at how I configure it. Oops. So as a standard, you would include source code management, but I don't have, and build triggers. What I want to show is this feature here as part of the Android emulator plugin. You can choose to run an emulator during build, and you can choose to have an AVD file that you created, or you can run it with properties. So you can actually specify all these properties during the build. So what you also have is able to show the window, use a snapshot, and also reset the state. And it's more advanced features that you can put in your emulator options. So then it comes to build steps. For build steps, I have the shell command that I mentioned earlier to set it to the right time, the current date and time. And the next step is to actually run an end target. It's just an Android build script. It's really simple. I can quickly show you what that is. And finally is to publish your HTML report. And this is actually a task in your Ant build, is to publish a HTML report. And just do a quick, oh, what happened? Let's see. All right. So I can quickly show you what Android build is. JUnit. So this includes all the jar files that is necessary. And the reporting part is actually using the JUnit report. There we go, right here. So this is a standard task, and you can find it from ant-apache.org. And similarly, this is exactly the same for iPhone, is to have the JUnit report as part of the Ant task. Okay. So let's go ahead and start running it. So build now. Did it build? There we go. Let's take a look at console output. Make sure this is the right one. Let's go back to project. There you go. So you can see that it's actually using a snapshot image. Let's see. So it's using a snapshot image. That's why it boots up so fast. What the next thing it's trying to do is connect to ADB. There is a defect in MonkeyRunner really, that the first time you start up the emulator, you will have a connectivity problem. So basically have a sort of setup test that will initialize the emulator, make sure that ADB is running. This only happens once. If you run subsequent tests, you don't have to do that. The connectivity will be available. And what it does, this test is going to do is add a contact. It will add a contact, find a contact, and delete a contact. And you'll see the same test will run on iPhone, exact same test. So let's go ahead and just add a name. Hello world. And I go ahead and find a contact. And this is all using MonkeyRunner. So it's found a contact, and I try to delete the contact. All right, and then you can see that the test is being published, the results. And you can take a look at the, let's see, build 19, the HTML report. Oh, let me just go back again. There we go. So this is part of app address book.test. And you can even get the screenshot, the name-only test that passed, the screenshot of the device, the last screen that part of the test. This you would have to configure. This is just using a style sheet in JUnit that you can change the display and include the snapshot as part of your results. So let's take a look at iPhone. Let's see. For iPhone, let's look at how I configure it. It's pretty much the same because it's a non-instrumentation approach. You would run it pretty much the same way as the Android. And this shell script is basically just to start it. You don't have to really start it. You can start it as part of a test, but I just want to make sure that it's consistent and reliable, that I start it and then have the test just launch and run. And again, the build file is exactly the same as Android, except for different jar files that are included. And then you publish your test result. So let's go ahead and build that. And what you're going to see is the same test that's being run. So you will add a contact, find a contact, and delete the contact. And this is using Sikuli and Mouette. It's the same test that's been running to add this, same user data, if you've seen Hello World. And that's it. And it runs really fast in iOS. Okay, and you can take a look at the, the results. So it's iOS, and again, the tests. And you can see the screenshot. That's the last screenshot that was being saved. And you can also take a look at the console output. That it's compiling and running a test, the same tests that you see earlier. And it does a dump of the screen text that you see. And does all the clicks and typing events. So that's for iOS and non-instrumented. So just want to quickly run through what is that for instrumentation approach. And I'm not going to run it, but I'm just going to show you how it works. And this is a Robotium test. And what I do is, because I have a location test that I need to run, so I can't use the emulator plugin, So I just have to start with my own command, its own shell script that I create just to start it up and check the status and before I launch my test. And then just call the shell date command to set the current day. Next thing I want to do is uninstall, just in case that there are previous packages that was part of the snapshot. I just want to uninstall first. Next thing is to clean, debug, and install. So this is part of sort of Robotium steps that you can follow. All I want to do is clean, debug, and install. I want to run my test separately. I don't want it to run my test. I know test is an option in it. The reason why I don't want to run a test is because I want to run it with a JUnit test runner. So this will actually run the test with arguments to specify where my report file is, the JUnit report file. And since the tests are being run on emulator, I want to have to pull it out. I have to pull it out to my local drive, and then I publish the results, right, in JUnit report. So the difference is that you have to pull the results is because this is instrumented. Your results are on the emulator or device. But non-instrumented approach, your test results resides on your system. You can take a look quickly at the latest test results. So you can see that this is standard JUnit test reporting. Since we have a little bit of time, I'll show you what instrumentation for iOS configuration is. It's a little more challenging because I'm using the UI automation framework, and the UI automation is not a really full-fledged harness per se. It's actually just ability for you to run your tests. So what you have to do is actually that you have to have a script such that or write in Java or write a CI plugin would be great, that users could actually find all the tests, the JavaScript tests that you want to run. And it will pick. So this is basically the script that picks out all the tests in this folder called acceptance, all the JS tests, the JavaScript tests. Will run it, and then it will actually have another script to translate those results. What UI automation does is actually has a plist file, results file that you have to is a key value pair. You have to translate that, or you have to parse that such that it becomes a JUnit format. If not, you just get a plist key value pair. And so then you can see the test results is exactly like a JUnit. And then you have a test, test name and so on and so forth. So exactly the same. All right. So let's go back to our presentation. So promise these are the resources that would be of interest, so that's covered in the presentation. And then we'll have some time for questions. I guess there's no mic. Just shut up. Uh-huh. Sure. Mm-hmm. Mm-hmm. Okay. So the question is, the test that was being shown takes about a minute to run, or some takes half a minute to run. So this is what I've noticed in end-to-end on mobile automation tests. That does take quite a bit of time to run them. So what we try to do is to limit the setup. So if you are logged in already, then you want to validate the screen in one test as much as possible. And so you don't repeat the login over and over again, or it takes a long time to run. So what we tend to do is having acceptance tests, have a user logged in, and then we go through all the different checks on different screens, and then log out and done. So this will shorten your test quite a bit. Yeah, it's definitely a limitation in mobile, as in it's not as fast as a web app. The other option is what you've seen here is that I'm actually showing the emulator window. So what I heard is that if you run it headless, it might be faster. So that's one option, but I haven't really looked at that. It is open source, but there are many options. There's Hudson and Electric Cloud, or there are many different options that you can take a look at it. But it's just one option that I use just for the demo to show that you can integrate that into a CI environment. So pretty much any C environment, you should be able to integrate it because all the commands are standalone, right? If you install the ADB commands, you should be able to access it. So you should, most CI tools should allow you to integrate build steps that includes executing Ant tasks and so on and so forth. Mm-hmm. Okay, so the question is, the tests, are they recorded as a record and playback test? In this case, the tests are not record and playback. Is the user has to programmatically say where you want to enter your text, where you want to click, and so on and so forth. So it's not a record and playback tool. But there are options to allow you to do a record and playback. It's just that I prefer to have it in such a way that we can be reusing the test, so that if the app changes in different ways, we can try to minimize that code change in our tests.
So the buttons that gets clicked and stuff on the screen, so those are just referenced from the script by the name or something, right?
Sorry.
You're saying that the buttons that gets tapped on the screen, they're just referenced by the label or something?
Correct. So the question is, how do we click a button and so on and so forth? So in instrumental technique, you actually would know what the button is, the name of the button, so you can actually find a button and click. Non-instrumental technique, you can click based on the location of button, or you can find image, or you can if the text of the button is not, it's easy to get text that Sikuli can actually find the text and actually press it if it's clear text. So one question in the back. Mm-hmm. 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 Okay. So the question is, was there a possibility to actually record as a video so that users could see the events that happen in the video file and not just images? You can definitely do that. You can integrate that. Because it's a non-instrumented approach, you can definitely do that because you can start off your recording session and stop at the very end. But non-instrumentation, you can do that too, part of CI. You can have it as part of a build step before you execute a test. The only problem is the size, right? I mean, it's the same as web application, right? How much memory you have to store in your built machine. That's definitely doable. It's just that we actually try not to do that. We try to save PNG files, images, because we want to limit the amount of data that we're keeping and the amount of maintenance that comes with it. Uh-huh. Okay, so the question is around Android OSs. There are multiple different OSs, and how do we test with all of them? Is that right?
Yeah, cloud-based services that
Mm-hmm.
provide
Mm-hmm. Okay. So what we've found so far is that we've been trying to do more functional testing around that runs continuously in CI with the most prevalent OS. So once at least we know that prevalent OS does, nothing breaks on that prevalent OS and our features are stable, then we looked at different OSs, especially the new features. But so far we have seen that, there are only, very minor issues with different OSs. It was not one of our biggest pain points. I think the biggest pain point is actually functional verification on, that we have to repeat all the time. If the server-side changes, database changes, and all that we have to validate the client side. Sorry, one question in the back. Sorry.
What do you use to compile the backend? What's your identity version might be installed on the Mac, so it will be a problem finding the export model. But with that your standard setup, what do you use some kind of another plugin to compile the export projects on the Jenkins install on the server?
So we have for Mac, for iOS, we would have a Mac machine that does our builds and run our tests at the same time. Android you can pretty much run on any systems. Yep.
For that step, you showed
Yes, so the question is where the setup is. So if you go to, so you're talking about the CI setup, or? So all the source code is actually in GitHub, ing/Mouette tree, under the tree. So I actually have all the address book test. The source code is being checked in. So you can. So the only thing about Jenkins setup is really, have you seen earlier, is pretty straightforward. It's just the ant and the Android emulator plugin. So I can't really check that in anyhow because it's really a Jenkins environment. Yeah, you can sort of revisit the presentation. Yep, that's a good one. Thank you. Any other questions? All right, one last one. Code coverage? The question is around code coverage. So at this point, we haven't attempted to look at code coverage because we're actually trying to get as many tests automated as much as possible and trying to get it into CI running consistently and reliably. So I think the next step would be to look at code coverage. Yep. So thank you, everyone, for your attendance. Thank you so much.